Welcome to AI Podcast. I'm Daniel, and today we're unpacking a fresh EMNLP paper called Alignment for Efficient Tool Calling of Large Language Models.
I'm Maya. Give me the quick headline first. What's the one thing our listeners should remember?
The big idea is this: teach a model to call tools only when it truly needs them. Think of a built-in sense of its own limits, plus a cost meter. The result is fewer unnecessary tool calls, roughly cut in half, while keeping accuracy about the same.
So it learns when to phone a friend and when to trust itself. Nice. Who's behind it?
Led by Hongshen with colleagues at Shanghai Jiaotong University, supervised by Kai Yu and team.
Great. Now, when you say the model knows its limits, what does that actually mean?
Picture a trivia night. Some questions you know cold, some you clearly don't, and some live in that gray, maybe zone. The paper calls this the knowledge boundary. The model estimates whether a question is inside its comfort zone or outside, and uses that to decide whether to call a tool like a calculator, a search retriever, or even another reasoning model.
And the cost meter you mentioned, how does that come in?
The authors treat tool use like a trade-off. Correct answers are good, obviously, but tool calls have a price in money and time. So they define a simple utility: better if it's correct with no tool, still good if correct with a tool, worse if it's wrong, an extra penalty if it's wrong, and you also burn tool budget. That utility becomes the target for training and evaluation.
A kind of budget-aware conscience. But how does the model estimate that gray zone, the area where it's unsure?
Two ways. First, a consistency trick. Ask the model the same question multiple times. If its answers agree, confidence goes up. If they scatter, confidence drops. Second, when ground truth is available during training, they compare the model's sampled answers to the actual answer to calibrate a more direct estimate of knowledge.
Okay, so it learns a feeling for "I've got this" versus "I should get help." How does that tie into training?
They try two flavors. Implicit modeling means you fine-tune the model to make the decision directly, answer now or call a tool. Explicit modeling means the model produces an answer plus a confidence score, and at inference, you set a threshold. Above the threshold, it answers. Below it, it calls the tool.
Which is handy because you can move that threshold if your tool gets cheaper or slower, right?
Exactly. It's like a thermostat for tool spending. If your retrieval API doubles in price, you tighten the threshold so the model relies more on itself unless it's really uncertain.
What did they test this on?
3 representative setups. First, arithmetic with a calculator tool. Second, open domain questions with a retrieval system, basically search for supporting facts. Third, math word problems where the tool is an external reasoning model that can think longer. They ran these on compact open-source models and compared against simple baselines like always using the tool, never using the tool, or basic confidence rules.
And the punchline?
The alignment method delivers the best overall utility in all 3 setups. In plain terms, it avoids wasting calls when the question is easy and spends on tools when the question is genuinely hard. Tool calls go down by about half compared to naive auto-tooling, without giving up accuracy.
That's appealing operationally. Less latency, less spend, same outcomes.
Right, and the latency angle matters. If you don't hit a retriever or an external model unnecessarily, you shave seconds off the response. The plots in the paper shift toward the sweet spot of faster and just as accurate.
I'm curious about the baselines. How did the naive approaches behave?
The always use the tool baseline wastes budget on easy questions. The never use baseline saves money, but predictably misses tough ones. A simple auto-tool rule based on a single confidence score improves things a bit, but it's not calibrated to the actual cost of each tool. The proposed alignment bakes that cost in, so the behavior adapts.
You mentioned calibration. Did they tweak the training data to nudge the model's instincts?
They did. They varied the ratio of examples that encourage tool use during fine-tuning. Too little and the model becomes overconfident. too much, and it leans on tools. There's a sweet spot where the utility peaks, and it shifts depending on how expensive or slow the tool is.
Makes sense. If your calculator is cheap and instant, you tolerate more calls. If your external reasoner is pricey and slow, you're pickier.
Exactly. Think of it as tuning a dial to match your back-end reality.
Let's ground this with an analogy. Suppose I'm a chef. Some orders I can do blindfolded, some need a recipe check, and some I should hand to the pastry expert. The system is training the chef to recognize which path to take, given the line is busy and ingredients are pricey.
Perfect. And the pastry expert is like that external reasoning model. Amazing when you need it, but you don't pull them over for toast.
Totally. Any details on the retrieval setup? Was it fancy?
It was a solid, standard stack. They used a proven retrieval toolkit rather than an exotic custom index, which makes the results easier to reproduce in principle.
Speaking of reproducibility, what should we be cautious about?
A few things. First, the study focuses on 3 tool types. Real deployments juggle more: code execution, web APIs, multimodal tools. Second, the cost dial was chosen by the authors. In production, you'd want to estimate or learn that dynamically as prices and latency change. Third, some training prompts were model-generated for variety, which could bias style. And finally, the experiments use open models. Closed models have different internals, so confidence estimates might not transfer cleanly.
So it's promising, but not plug and play for every platform tomorrow morning.
Right. It's a blueprint with strong early results.
Did they say which of the 2 training flavors worked better?
The version that explicitly predicts confidence tends to calibrate decisions more smoothly across different tool costs, but both beat the naive baselines, and the implicit one is efficient when you're fine targeting a particular cost regime.
Any surprises in how the model behaved?
One neat pattern. Under the proposed alignment, tool calls concentrate on the hardest items. With naive auto-tooling, the call rate was flatter across easy and hard questions. That shift is exactly what you want.
I like that. It's like a triage nurse learning to spot who really needs the specialist.
That's the spirit of the paper.
If you were implementing this at a company, where would you start?
First, log actual latency and dollar costs for each tool in your stack. Second, set a simple utility target that reflects your budget and SLA. Third, fine-tune a small model with explicit confidence output, then adjust the threshold over a week of traffic and see how tool spend and user satisfaction move. Keep a human-in-the-loop dashboard so you can audit when the model chooses to spend.
And future research?
Learning the cost dial automatically, choosing among many tools or sequences of tools, and expanding tests to real messy user traffic. I'd also look at better confidence training, like proper scoring rules, and adding safety constraints so certain tools can't be used in sensitive contexts without approval.
Before we wrap, can we restate the takeaway in one breath?
Sure. Align models not just for truthfulness, but for cost-aware judgment about when to use tools. You get fewer wasted calls, faster responses, and similar accuracy because the model learns its own limits.
And the kicker is that the approach is simple enough to try. Estimate uncertainty, attach a cost, and train the model to make the call like a thoughtful teammate.
Exactly. Smart help, not reflexive help.
That's our show. The paper is Alignment for Efficient Tool Calling of Large Language Models from Xu and colleagues at Shanghai Jiaotong University, presented at EMNLP.
Thanks for listening to AI Podcast. If you like this breakdown, share it with a colleague who is tuning their tool stack, and we'll see you next time.